Let's look at the properties of vector product. If you have A crossed with the same vector A, that will give you a zero vector. Because if we try and apply the first equation of vector product when you have the angle theta, we know that these two vectors A will be parallel because they are the same vector going upward. Say for this example, so you can see that there is no angle between vector A and another vector A, right? So this means that our theta will be 0 degree. And we know that sine 0 is 0. Therefore, the whole thing here will be 0, and then when it times with another vector or the unit vector, that is still a vector. So that's why it becomes 0 vector. Next, if you have A cross B, you already know that it is equal to negative B cross A, because these two vector, A cross B and B cross A, will be negative vector. So say that A cross B goes upward, therefore B cross A will be the other direction, the opposite direction. Therefore, this is actually negative A cross B. Say that we have a constant in front of A cross B. Therefore, when you expand it, this will either be MA cross B or maybe A cross MB. But if you have A cross B plus C, if we expand it, it can be A cross B plus with A cross C. And if you have A plus B cross with C, it will be A cross C plus B cross C. But what if you have scalar product and vector product in one expression? Like this one, we have A dot with B cross C. So you can actually swap the two position of the scalar product and vector product. So it will be A cross B, you dot it with vector C. Now what if we have two vector product in one expression? Say vector A cross with B cross C. In this case, you need to memorize this formula. A dot C times with vector B minus A dot B times vector C. And don't forget that whenever you do the scalar product, which is A dot C and A dot B right here, they are just constant. So that's why right here, this is time, because constant can be time or multiplied with any vector. So it's actually a constant times with vector B minus with a constant times with vector C. Next, what if the vector A is parallel to vector B? So we know that parallel means same direction or different direction. Say that the two vectors are in the same direction. Therefore, the angle between these two vectors is 0 degree. And we're going to use the first equation of vector product. Since we have the angle theta, change theta to become 0 degree. And we know that sine 0 is 0. Therefore, the constant will become 0. And it will be 0 times u hat. And therefore, the final answer will become 0 vector. But if A and B are in different direction, this means that the angle theta between these two vectors is 180 degree. So we can use the same formula since we know theta. Change theta to become 180 degree. And we know that sine 180 degree is 0. Therefore, the whole thing here, which is the constant, will become 0. So it's just 0 u hat, which is equal to 0 vector. Therefore, we can make a conclusion that if the vectors is parallel, either in same direction or different direction, the vector product is always zero vector.